I'm Mahathi Manjipudi with Global cli-MATES, and welcome to another Introductory Earth Sciences video. Today, we'll be taking a closer look at Earth's crust. So last week we did kind of a bigger overview about the various layers in Earth's geosphere, and today we're going to specifically focus on Earth's crust. And so, as you may recall, on our planet we have a few layers. And Earth's crust is the relatively thin layer of rock that we see directly on the surface. So it's actually this very thin layer right at the surface of Earth, and it's where we live. It's where we live, eat, sleep, breathe. Same with where all the plants and all the animals exist. That's Earth's crust. Now there's actually two primary types of crust. So we have crust as a whole, but crust itself is broken down into oceanic crust and continental crust. So as you can imagine, some parts of Earth's surface are covered in ocean, and some parts of Earth's surface is covered in land, right? So continental crust is quite literally the physical land we see, oftentimes. And then the oceanic crust is, well, if we think about the oceans, underneath all that water, there is more rock right at the bottom. So, for example, if you've ever been to like a lake, and you are walking along the lake, you might feel the bottom, right? So, in the case of oceanic crust, it's not found underneath lakes, it's found underneath oceans. But again, it's kind of like that bottom surface of the ocean. And so these two types of crust are actually pretty different, and we'll talk a little bit about their various properties in this video. So starting off with oceanic crust, as I mentioned earlier, we have our ocean, and underneath the ocean we have this dark rock. All right, and so this dark rock is what makes up the oceanic crust. And typically, oceanic crust is composed of a rock called basalt. And so basalt is an igneous rock that forms on the ocean when it erupts from various cracks in the oceanic crust. So this hot basaltic magma will come up through those cracks, and as it cools down in the water, it will form more oceanic basaltic crust. Now, the oceanic crust in and of itself is approximately 7 kilometers wide on average, so this is approximately 5 miles. And so anywhere you go, typically if you are under an ocean and you want to know how thick the layer of oceanic crust is, it's going to be approximately 7 kilometers thick. And then the other thing that we can also, another property we can think about is density. And so if we think about, well, where is oceanic crust? Oceanic crust is underneath this ocean. It's one of, the lowest parts of Earth's crust as a whole. And so we can think that, it's probably going to be pretty dense. And in fact, its density is 3 grams per centimeters cubed. And so density, if you don't know, density, this is just a quick little tangent, but density is equal to mass over volume. And so that's kind of this measurement, right? So grams is from the mass and centimeters cubed is from the volume. And for reference, if you think about water has a density of 1 gram per centimeters cubed. So the density of oceanic crust is roughly 3 times that of water. And then another thing to note is when we're thinking about the composition of oceanic crust, it is mostly homogeneous. So what this means is, the oceanic crust is primarily made of only one type of rock, which is basalt. So moving on to continental crust. Continental crust, as I mentioned earlier, is what we see on land. So, we see grass, and then underneath that grass, we have a lot of dirt. I guess we'll use this reddish color for dirt. And we have a lot of rock underneath that. So continental crust is this, rock. But if we think about land, we also see a lot of features, right? So we see plains, these flat plains, and then we see these, these huge mountains, for example. And while these features do also somewhat exist on the ocean floor, the ocean floor still has that average 7-kilometer thickness, right? That's not the case with that's not the case with continental crust. Continental crust, there's a lot of variation, but if we were going to stick with an average, it would roughly be 35 kilometers thick, which is roughly 22 miles. But as I mentioned, we also have, for example, mountains, and under mountains, it can get up to 70 kilometers thick underneath those mountains, which is like 40 miles. And the other, variation and diversity we see with continental crust is, well, if you've been to, different places, you might have noticed that you see different rocks. Maybe it's like the color, for example, of the rocks you see on the side of the road. Like if some roads have, like, for example, these outcrops where, part of the rock is, like the roads cut through the rocks, right? So you can kind of see, what does the bedrock look like in some regions. And, you might notice that there, like, it looks different in different places. And that's true. There is a lot of variation in rock type on continental crust. And because of that, we can't say that, it's mostly homogeneous, right? Because there is so much diversity. However, there is the crust, the upper continental crust, is most typically made up of granodiorite. So if you've heard of granite, for example, granodiorite is kind of, it's a granitic rock. So it's similar to granite, so maybe you have like a granite countertop. It's a rock similar to that. And then if we go to density again, we can see that continental crust typically averages 2.7 grams per centimeters cubed. And we can actually compare this with, the oceanic crust. And as you can see, oceanic crust is denser than the continental crust, which makes sense because continental crust, right, is, at the surface, and then, several thousand meters below, we have the oceanic crust. So, you can kind of think again about how more dense rocks and elements sink closer to the center of the Earth, whereas the lighter rocks and elements are near the surface. So we can see that again. And actually, this does give us a clue about the composition of the crust, because we can see that, well, if, the continental crust is primarily composed of granodiorite, well, then granodiorite should have a lower density than basalt. Just by, just by knowing that basalt primarily composes oceanic crust, and granodiorite is a large part of continental crust. So this was all for today, just giving some more specifics about the two different types of crust, so that you're more well informed about, what crust actually looks like on planet Earth. I hope this video was helpful for you all, and if you did find it helpful, please like and subscribe and share this video with other people. And if you have any questions or suggestions for future content, don't hesitate to comment down below. See you all in our next video. Bye!